Let's look at quantitative data analysis and some of the techniques used here. When people talk about quantitative data analysis, it often sounds like a long list of confusing terms in SPSS or Stata. But at its core, it's really just a set of tools for answering different types of questions using numbers. So instead of memorizing names, it helps more to understand what each technique is actually doing. So let's start from the very beginning. We have frequencies and percentages. This is the simplest form of analysis when it comes to quantitative. This tells you how many people choose what. For example, if you ask students their year of study, frequencies will show you how many are in first year, second year, and so on. Then percentages then convert that into proportions. So instead of saying 40 students are in first year, you say 40% of respondents are first year students. This is usually your starting point in any analysis. It helps you understand who your data actually represents. Then we have the mean, median, and mode. And these are called measures of central tendency. But the idea is very simple. They tell you what a typical response looks like. So, typical. For example, imagine students rating their stress level from 1 to 5. The mean gives you the average stress level across all students. The median gives you the middle value when responses are arranged in order. And the mode tells you the most common response. So if most students selected 4, the mode would be 4. This helps you summarize attitudes or behaviors in one number instead of a long list of responses. So those are the measures of central tendency. Then we have the standard deviation. This one sounds technical, but the idea here is also very intuitive. Standard deviation tells you how similar or different your responses are. For example, if all students selected around 3 or 4 for stress, then the standard deviation is very low. That means students are fairly similar. But if some selected 1 and others selected 5, the standard deviation is high. That means responses are spread out, they vary. So it doesn't just matter what the average is, it also matters how consistent people are. Then we also have cross-tabulation when it comes to data analysis. This is where you start comparing groups. For example, you might want to see how stress levels differ between male and female students. A cross-tab table shows both variables side by side so that you can see the patterns like more females reporting high stress compared to males or even vice versa. It is a simple but powerful way to explore relationships before doing deeper tests. Now we have correlation analysis. Correlation is used when you want to know whether two variables move together. For example, do students who study more hours tend to have higher grades? If yes, that is a positive correlation. If one goes up while the other goes down, then it is a negative correlation. But correlation doesn't tell you why. It only tells you that a pattern exists. It is more about connection and not explanation. Then another data analysis component here is t-test. So a t-test is used when you are comparing two groups. For example, do male and female students differ in academic performance? Or do students who attend lectures regularly perform differently from those who don't? So you are comparing two groups. So a t-test helps you check whether the difference between two groups is meaningful or just random variation. Then we have ANOVA. ANOVA is similar to a t-test, but it is for more than two groups. For example, you might compare stress levels across first year, second year, and final year students. Instead of multiple t-tests, ANOVA tells you whether there is a significant difference somewhere among the groups. That is it. Then we also have a regression analysis. Regression goes one step further. It doesn't just ask whether variables are related. It tries to understand how one variable can predict another. For example, can study time, attendance, and sleep predict academic performance? Regression tells you which factors matter most and how strong their influence is. And that is it. So, quantitative analysis is not random software output. Each technique answers a different type of question. Frequencies tell you who your data is. Means tell you what the average response looks like. Standard deviation tells you how spread out your responses are. And cross-tabulations show group patterns. Correlation shows relationships. T-test and ANOVA show differences in groups. And regression shows prediction. And once you see it this way, SPSS or Stata or whatever software stops being confusing because you are no longer clicking buttons, you are choosing tools based on questions. And that is what real quantitative analysis actually is. I hope this helps, and I'll see you in the next one.